Welcome again to another action-packed episode of Empowering Introductory Algebra. I'm Bob Young, Assistant Professor of Mathematics at Brevard Community College. Along with my excellent support staff of WBCC, we continue to bring you top-notch algebra lessons that you can work on anytime, convenient to your busy schedules. Let's continue the journey. Now, as we left off in our last lesson, we were talking about factoring the greatest common factor out of polynomials. So let's go back to the graphic there real quick and just touch on that. And we talked about this late in the last lesson. To factor a polynomial with more than one term, take out the greatest common factor, divide each term by that greatest common factor, and put what's left in the parentheses. So what you end up with is the greatest common factor times the parentheses. Now in the next graphic here, we can check this by distributing the greatest common factor back through the parentheses. And write this in your notes now. These graphics are for your benefit. Make sure that nothing in common is left in any of the parentheses. You always want to make sure nothing in common is left in the parentheses. So let's go back to the example I finished up with at the end of the last episode here. Let's straighten that out. We had a real nasty one with 48 and 240 in there, and we were thinking about numbers that would go in here, and we said, well, what if we didn't get it all? What if we missed part of it? I just took out a 12, but when I took out the 12 and the x, which we found was in common, I was left with the 4x cubed minus 20, and I said, aha, there's still something that goes into each one of these, so I had to take the additional 4 out. So not only check by distributing it back through, make sure that in all parentheses there's nothing left in common here, and that will be a common theme throughout the rest of our factoring adventures. All right, and I'm going to go ahead and continue now. I call these type problems when we factor out the greatest common factor the bye-bye. Now, people are going, bye-bye? What's that mean, Young? And you could think about some old songs. Bye-bye, Miss American Pie. Well, I better not sing, I might scare people. But they do have a more contemporary one now. You got the bye-bye-bye. You know, I won't talk about groups or anything. But the bye-bye, the reason I call this a bye-bye is this is a binomial. This is one term. Now, I know it looks like a whole bunch of terms, but this is one term, and then this parentheses means these are multiplied together, leaving this as one big term, as is the 2 and the parentheses. See, so this is a binomial, and it doesn't take Einstein to see what they have in common. Gee, what does this have in common, I wonder? Yes, you can take out the 3z plus 1. Now, how many 3z plus 1s can I take out of each one of these? Sometimes I'll see students make a mistake. They'll put a square here. They'll put, well, there's 2 of them, so I'm taking 2 out, but each term only has how many? 1. Don't try to take something where there's not something to take. Yeah, so 1 3z plus 1 comes out, and if you want to, just like we did in the previous lesson, you can write that greatest common factor right underneath each one, and then put what's left in here. Yeah. So what's left, it doesn't take a lot to see either. Those cancel out, leaving you with the 5z squared. These cancel out. We'll go ahead and just do a little chopping. We haven't chopped in a while. Let's chop. Yeah. So we'll end up with 5z squared plus 2. All right. Anything in common in here? No. Life is good. And I could check this by foiling it, but to check it, I would have to foil this, get an answer. Then I have to go back up here, distribute this through, collect like terms, but you would end up with the same thing in the wash. So you can actually check those as well. Next example, another bye-bye. I'm going to underline each term. And again, you can see a common what? 2x minus 5 is in common. So I'm going to pull the 2x minus 5 out, and I'm going to write that right underneath each term, 2x minus 5 very quickly, and we'll put what's left in here. What's left? Well, in this one, it's easy to see what's left. When those cancel out, you're left with the 7x to the third. But how about over here, Young? There's no number in front of the parentheses. Or is there? The old hidden one is there, yes. And remember, if you divide anything by itself, it always leaves you with what? 1? What kind of 1? Well, we had a minus there, so there's going to be a minus 1 left. So this is how you factor the by. You can take a binomial out and then put what's left. All right, continuing, let's go back to the next graphic here. And the next concept we want to talk about is when factoring 4 terms. Oh, Young, they're getting larger. Yes, these polynomials will increase in size. When factoring 4 terms, we like to use the expression factor by grouping. And when we do that, we want to first arrange the polynomial in descending order of powers. Now, a lot of times they do that for you in the introductory books, but in the nastier books, when you get to the college level classes, they don't. So go ahead and make sure you put it in descending order. And then you want to also look at which groupings have common numbers or variables in them. So you kind of have to match things up when you do these factor by groupings. And be sure to separate the 2 parentheses with a plus sign. Now, I know what some of you are thinking about that last statement. What do you mean by that, Young? So we'll go to some examples here and we'll illustrate. Okay, back to the examples. So notice I've got factor by grouping. Always do this when you have 4 terms, and it's easy to tell when you have 4 terms. These next 2 examples do. 1, 2, 3, 4. 1, 2, 3, 4. And notice I have them all in nice what kind of order? Yeah, descending order of power. So you want to arrange them in that. So when we group, we're going to go ahead and notice there's some common things in the first 2 terms and in the last 2 terms here. So I'm going to just go ahead and slap some parentheses on that. Now, why is the plus sign so important here? Well, if it wasn't a plus sign there, that would look like what? It would look like you're multiplying, or you'd have to FOIL these things, wouldn't you? See, so that plus sign is real important there. Right. Now, what I'm going to do now is, what do these first 2 terms have in common? I'm going to take the greatest common factor of these first 2 terms out. And I think if you've been practicing some we've been talking about in the past, you would say, well, gee, Young, it looks like a 5x squared comes out of each one of these. And when I take that 5x squared out and divide each term by it, what's left in here? Well, I'm going to be left with 2x minus 5. And then you do the same thing to the second pair you've grouped here. What comes out of these 2? What goes into 4 and 10? This is the largest number. The greatest common number that goes into 4 and 10 is a 2. So we're going to write plus 2 there and divide each term by 2. What's left? 2x minus 5. Now, something look familiar with what we just did here? We took the greatest common factor of the first 2 and wrote it. Greatest common factor of the second 2 and wrote it. And yes, we can start singing a song here. Bye, bye, Miss American Pie. There it is again. Or bye, 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 whichever group you're from. So now you can take that 2x minus 5 out and then put what's left in the parentheses. All right, there's that common 2x minus 5, and you can write it right underneath here if you want to. So I'm always taking the greatest common factor and I'm sneaking it underneath all these things. And I always put the greatest common factor as the first part of my answers in all these. All right, so I'm left with 5x squared plus 2. Right? Now, anything in common in these parentheses? No. So life is good. And if I FOIL this, watch what happens. The first 2 terms, 2x times 5x squared, gives me what I started with up here, 10x cubed. The outside 2 terms, 2x times 2, 4x. Oop, there it is. The inside 2 terms, minus 5 times 5x squared. The inside 2 here, it gives it a smiley face. Remember the smiley face of FOIL? Minus 25x squared. And the last 2 terms, minus 10. So this will indeed FOIL, okay, FOIL to check. So these factor by grouping problems you can check by FOILing. I like it. All right, let's try one more here. Now on this one again, it's in descending order, so we're going to go ahead and group first 2 terms and last 2 terms. Now I'm going to have to sneak my plus sign in there because again, this looks like multiply if I don't. So I'm going to crunch a plus sign between there to show these are separated by an addition symbol. All right, greatest common factor of the first 2. Let's see how good you're getting out there. 2 goes into the numbers. How many y's? 2 y's also are in common. So we can take out 2y squared out of these first 2 and then put what's left in here. So I'll go ahead and put that greatest common factor right underneath each term and divide, get my ducks in a row, and I get y plus 6. Now on the second 2, you have to be kind of careful here with signs. I can either take what kind of 5 out? I think everyone sees there's a 5 in common, but I could either take a negative 5 out or a positive 5 out. Which is it, Young? Well, remember, when you factor by grouping and do it right, you want to try to get to our friend the bye-bye. All right, so you want to try to force that bye-bye when you can. So what we're going to take out here to do that is a negative 5, and I'll show you why momentarily. So we'll go ahead and take that negative 5 and line it up there, and watch what happens. Negative divided by negative gives me what kind of y? Positive. And again, negative divided by negative, plus 6. There it is. Bye, bye, bye. The binomial with a binomial in common. So you could take that common y plus 6 out and put what's left in the parentheses, which in this case would be what's in front here, the 2y squared minus 5. Foil that, you'll get what you started with back, guaranteed, or your money back. All right? Don't tell your admissions office I said that. All right, next thing we want to talk about, we want to stop here at this point and talk about some more avenues for help for students. All right, so the third avenue for help I want to discuss is see if your campus has videotapes to check out. A lot of the algebra courses that we teach often come with videotapes, and you can check them out and watch your sections topic by topic. It might even be better than watching me, I don't know. But you'll have all kinds of avenues out there to help you. And many math courses also have computer tutorials available. You know, you might want to check your computer lab and they correlate with the given textbooks. So, I mean, all kinds of things out there for students for you to get help learning if you need it. So keep that in mind as we go along. Now, looking at the next graphic, we'll go ahead and continue our adventure in factoring. We're going to start factoring trinomials. Now, trinomials will be in the form ax squared plus bx plus c. Now, don't worry about the ABC part. You know, the ABC part is just numbers in front there. This numbers are numerical things. And we're going to factor first when a, the number in front of the x squared there, is equal 1. Let me bring my hand up here. So this a in front of the x squared is always going to be 1 in the ones we start out with. Now, the rule here is if a trinomial will factor, the factors of a times c, now let's go back up top here, the outside numbers, the one in front of the x squared times the last number, the factors of a times c will always add to give you this middle number, b. Okay? And I call those rainbow numbers. And I can hum another tune for you. Somewhere over the rainbow. So let's go to our examples and we'll look at some of these. All right, now, oh, look at the color here. We just give you the color on the BCC network here. I tell you, the rainbow numbers. All right, so find the rainbow numbers. Now, what I call the rainbow numbers, this gives you the O and the I part of FOIL back. So when we factor trinomials, we're going to what's called unfoil. All right, now what number's in front of this x squared? Young, I don't see one. It's 1. So I'm going to go ahead and take these numbers, a and c, and multiply them together. 1 times 12, 12. All right, then I'm going to list all the factors of 12 over here. Now remember, factors, if you multiply or take products, will give you that number back. So factors of 12, 1 and 12, 2 and 6, and what else? 3 and 4. Now, looking at all these factors of 12, I wonder which of the pairs will somehow give me this middle term. It doesn't take a lot, does it? Ha-ha, 3 and 4 somehow will give me 7 if I put what signs on them. So we want to go ahead and put addition signs. So what I call these are the rainbow numbers. The factors of the outside two multiplied together, these numbers will always add to give you that middle one. All right, so let's think about foiling in reverse. So when we break apart our two parentheses here, the first two terms would have to multiply to give me x squared. What would they be? What times what is x squared? Well, yeah, x times x. And remember, whenever you multiply same bases, add the powers. Now, the nice thing about the ones with the number 1 in front of the a squared here is that when you break apart these numbers and find what gives you the middle, that's the numbers that go right in here. So it would be plus 3 plus 4, or you could put plus 4 plus 3. It doesn't matter which way you write them. And we have just factored our first trinomial. All right, and if you FOIL that back, you'll get what's out here. Now let me show you why I like to call these rainbow numbers. I've got these colorful rainbows. When you do FOIL, x times x gives you x squared. The outside two terms, the 4 and the x, gives you plus 4x. The inside two, the smiley face here, gives you plus 3x. And you see those numbers correlate to here. Thusly named by Young, rainbow numbers. All right, and the 3 times 4 gives you the 12. So when you factor trinomials, you can hum a few bars of Let's do the next one. If I sing too much, the film guys will, I think they're pointing some guns and stuff back there. I mean, I won't say anything. All right, so anyway, 1 times 10 here, the number in front of the y square, 1 times 10, 10. Let's list all the factors of 10 real quick. It doesn't take long. 1, 10. 2, 5. I wonder which ones are going to give us what we need in the middle here. Yeah, the 2 and the 5. And if I'm going to put signs on these so they add to give me what kind of 7? A minus. The signs on the 2 and 5 would have to be both minuses, wouldn't they? All right. So when I go to factor this, what times what gives me y squared? Y. And then you know these are the rainbow numbers. You can go ahead and put them in either parentheses. You can put -2, -5, or -5, -2. And you also know when you check this that when you have a negative times a negative here, that's going to force a positive 10 here. So this sign right here, notice the last number sign kind of tells me if that's a plus and that's a plus, then both of these signs either have to be both pluses, where notice in this case, when you have plus plus here, they were both pluses, as are the rainbow numbers. Or if that's a plus and you have a negative middle term, and the only way that can happen is if both of these signs are what? Yeah, negative. And notice when the parenthesis signs are that, the rainbow number signs are that. So isn't that great? They match up. These signs in here match up with your rainbow number signs. Let's continue. All right, so we're going to factor some more trinomials. I tried to pick some nastier ones and mix signs up here on you and stuff. Don't panic. Notice I still got the rainbows. It must be a cloudy day. I separated them a little bit more. All right, so again, the number in front of the x squared is a 1. 1 times 72 is 72. Now, y'all are going, gee, Young, you're busting my chops here now. Well, there's a lot of factors of 72. And a lot of times, once you get to know this method, you won't have to write every single factor of 72 out to get the middle. But if we want to, we can, as we're learning here. So what factors of 72? 1 and 72. I like 1. He's a factor of everything. 2 goes into 72 because it ends in an even number. Anything that's even, 2 goes into 36 times. There's an old divisibility rule for the number 3 in your basic math class. I don't know if all of you remember this out there, but if you have 72, I know that 3 goes into that. And you know how I know? Because if you add up the 2 digits, 7 plus 2, you get 9. 3 goes into 9, therefore 3 goes into that number. So if it's a number that's divisible by 3, 3 will break it apart. So 3 goes into 72. How many times? Let's see, 24. And do I need to look anymore? Oh, there's that number in the middle. Yeah. So what signs would I have to put on the 3 and the 24 to get the minus 21? There's only one possible combination, and that's if I put a plus 3 and a minus 24. That way, the factors of the outside two numbers will add to give me the middle. See, that's how you find those coveted rainbow numbers. And when you do, you can feel the power surging in your veins. All right, so when we break this apart, what times what gives me x squared? xx. And then number-wise, we can put plus 3 minus 24 plus 3. It doesn't matter. I'm going to put minus 24 plus 3 just to buck the system. All right, so we can check these again by foiling. So if you foil this, x times x, x squared. The outside two terms, plus 3x. The inside two terms, minus 24x. And you notice those rainbow numbers, that's where they're going to show up. Somewhere over the rainbow, or under the rainbow, skies are blue once you find them. Multiply the last two numbers and you get the minus 72. Fits like a glove. All right. Let's try the next example. A squared plus a minus 42. we'll go ahead and take the 1 times the 42 here. Now don't worry about the signs right now. I think with that minus sign, some of you might want to put a minus 42 over here, and some of you might have asked me why I didn't put a minus here, but notice the signs will be different on these, so they'll add to give you that middle term, so don't panic there. So I'm just going to put plain old 42. Now what factors of 42 will give me, but Young, I don't see a number in the middle here. But there is one, isn't there? Plus A means plus what? Plus 1A. All right, which is what we want to make on our test, the A, yeah. So what factors of 42 will give me 1 in the middle? Do you want to write them all out, or do you see them? Let's think about it. Maybe some of you out there are thinking, how about 6 and 7, Young? That multiplies to give me the outside numbers, and if I put the signs right, I can get that plus 1 in the middle. Now, what signs would I have to put on the 6 and the 7 to get a plus 1? Well, it would be a minus 6 plus 7. So I love this method. You can never make a sign error. It's great. It's great. All right, so these are the rainbow numbers. Let's go ahead and break this trinomial apart. AA minus 6 plus 7 minus 6, it doesn't matter. You want to see another way to check these? I know you couldn't wait to see. There's other ways to check these. Plug in some numbers, folks. Let's put a number in here for A. I'm going to let, in this case, show you what happens here. A equals 0. It's a very easy number to plug in here for all these A's. What's 0 squared? 0. Plus 1 times 0? 0. So these really go out, don't they? Leaves me with a minus 42. So when A is 0, do y'all see here that I get a minus 42 out of this trinomial? Plug in 0 in. Let's do the same thing with this factored answer here. Let's put 0 in for A. And look what we end up with. 0 minus 6 is just minus 6, isn't it? 0 plus 7 is 7. Now look what I end up with. Negative 6 times 7. Are those factors that give me a negative 42? Sure is. It checks. See, and you could put any number in the universe in there, any real number for A, and you would get similar results. Isn't that cool? So there's lots of ways to check these things. And notice there's nothing in common in here as well. We'll come back to that in a second. All right, continuing our adventure here. Factoring trinomials in the form ax squared plus bx plus c when A is 1. My rainbows keep changing color. I hope you appreciate that out there in the audience. Now, one thing, hey, Young, this ain't in descending order. Let's get it in descending order. So I'm going to put that minus x squared first, minus 3x plus 108. So I just took it and wrote it in nice descending order. Now, why is it so important that A is 1? It makes it easier to factor. Now, is this A 1 here in front of the x squared? No, it's not 1, it's negative 1. So how do I get rid of that negative? Now, a lot of students will mistakenly, don't go here, dangerous place. They'll say multiply through by negative 1. But again, this is not an equation, so you can't go multiplying through by a negative 1. Don't go there. But what we can do is we can take and factor a negative 1 out of this trinomial and divide each term by negative 1. And what that does, it's going to change all the signs. So it changes the negatives into positives and the positive into negative. And if I multiply the negative 1 back through, I have not violated any rules. Okay. So now I'll go ahead and multiply. Let's take this trinomial inside here and deal with it. I'm going to take the 1 times the 108 and put 108 up here. Factors of 108 to give me 3. Now some of you are going, man, these numbers are getting larger. But don't panic. Let's go ahead and write them all out. This is going to help us with our divisibility rules as well. 1 times 108 is 108, but boy, that ain't going to get close to 3, is it? Nah. 2 goes into it because it's an even number. 2 goes into 108, I think 54 times, but that's still not going to give us 3. Will 3 go into this number? Well, if you add up the digits, 1 plus 0 plus 8, you get 9. Therefore, 3 will go into it evenly. All right, you can amaze your friends at parties with this. I don't know if you want to do this at parties, but we'll have a few drinks in you. Anyway, that's bad to say out there. I'm sorry. 3 into 108 goes 36 times. Doesn't work. All right. 4, let's see if 4 goes in there. I think 4 goes into 108, 27. So lots of combinations, but I still don't have the 3, do I? Now, there's a little rule for 6, a divisibility rule. If 2 and 3 goes into a number, 6 goes into it, guaranteed. If 2 works and 3 works, 6 works. 6 happens to go in there 18 times. Still not there. Still not there. Still not where I can get 3 out of this anyway, is there? 7 doesn't go into it. 8 doesn't go into it. Now there's another rule. The rule for 3 also works for the number 9. If you remember your basic math, 9 goes into 108 because the digits add up to be 9 or a multiple of 9. So that rule works like the 3 rule. And that rule will help us later too. 9 goes in there. Oop, there it is, 12 times. All right, so now to get our plus 3 in the middle, we can put what signs on the 9 and 12? We can put a plus 12 minus 9, and we have our rainbow numbers. We have our rainbow numbers. So now we can go ahead and leave that minus 1 out we took out, break this trinomial up, x, and then we can put minus 9 plus 12 minus 9 does not matter. Okay. Now there's the answer. Textbooks may write this answer differently. They might take that -1 and multiply it by one or the other of these. All right, so this answer could also be written as, and what they'll do is they'll try to use a commutative property and switch these around on you. They could also write that answer 9 minus x times x plus 12. If they wanted to take the -1 and multiply it through there, these two, same answer. Or they could leave the x minus 9 alone and multiply that by -1. Now, I don't see that one done very often, but these 3 answers would all be the same. Which one do we like the best? I like the one where we stay consistent and just keep that negative outside there. Okay? So, finding those rainbow numbers, the outside factors will always give you that middle one. It's like a mystery puzzle somehow. It's kind of neat. All right, let's try this one here. All right, y squared minus 7y minus 16 here. So if I take the outside numbers, 1 times 16, I'll get 16. All right, nicer number. People are going, thank heavens out there, Young, you didn't throw another 108 or something out of 16. That's nice. All right, factors of 16, let's list them. 1 and 16, 2 and 8, 4 and 4. All right, now let's look at this. I don't think there's any more factors of 16. I can't think of any more. I don't think there are any more. Can you? I don't see any more. So are there any ways I can get a -7 out of these pairings? I don't think so. So did you know out there not every trinomial factors? This is a trinomial, and I can tell because there are no factors of the outside that give you the middle. This is one that some textbooks put cannot factor, but what Young likes to write on these is prime, a prime polynomial. All right, so there are prime polynomials just like there are prime numbers. And think about prime numbers. We have prime numbers we can think about 2, 3, 5, 7, 11. Now what makes these numbers prime is that there's nothing that goes into it besides 1 in itself. All right, this is the same kind of creature here. All right, nothing breaks this apart. There are no factors that will give me that middle term, so I just call it a prime polynomial or cannot factor. All right, so we have been practicing today these factoring trinomials in the form ax squared plus bx plus c when a equals 1, and we'll come back to that in the next lesson. In closing, remember what it takes to succeed in mathematics: effort, desire, motivation, and drive. Stay focused, pay attention to detail, and always feel you can succeed. You may be surprised with the results. Take care, and we'll see you next time.